very good morning. Sometimes it's very humbling to hear those words describing yourself. It's a different feel somehow. But thank you so much for allowing us to participate in this event. It's always good to be able to be associated with the entrepreneurship, the startup event, and I feel the vibrancy, the passion, and energy as well. So I've been in the industry for a while, and we've been in a company called F5. Some of you probably would have heard of F5 if you've been in the industry long enough to know us as a load balancer company. Basically, essentially, providing high availability, resiliency. But today's topic is about APIs, right? And in the new world, we found that a lot of the communications between business partners and consumers are going to be transacted through APIs, especially in finance, right? So today I'm going to share a few things around APIs, how it's being used in finance, and what are some of the things that you should be aware of and how to protect yourselves from it. Yeah. So the few things that I think we are seeing in the market in regards to APIs. Number one thing is that quite often our customers starting to realize that the traditional security they put in place, be it the firewall or web application firewall, is just not sufficient for API security. And then they find out the hard way. By the way, they find out the hard way because either they got a data breach or there are some attack that happened. So that's the first thing. It is like they underestimated what the attacks could be based on the existing security infrastructure. Then the second bit is on the PII data. Unfortunately, when you're dealing with APIs, right, you are also dealing with some personal information. Any API that you publish, there is obviously some value to it. Because the reason why somebody is calling you is because they want to get some value out of it. So the end result in API is to do something for the customer, and it does contain quite often PII data that you need to be concerned about. The third thing is that it's very easy to API sprawl. The way you're going to be doing remittance today is going to be APIs, but it's so easy to just publish an API. Or let me build a testing API for my own testing. So it's pretty easy to get that sprawl. And when that sprawl takes effect, you lose control, essentially. Yeah, and that's where compromises may take place. Now, before I get into all the issues with APIs, this is not a scare tactic, by the way. These are real case studies published in Singapore of what happened in those situations where APIs were compromised. I'm part of the OWASP. For those of you who don't know, OWASP stands for Open Web Application Security Project. It's a kind of open source, open community that talks about all the app vulnerabilities, API vulnerabilities. And this is actually documented by the OWASP leader in Singapore. And he talked about just two cases of API compromise. The first one was Comissure. Now, by the way, all these are public information. It's documented, it's published. So, this particular company was, they lost a lot of customer records. You see there's like 5 million, including customer name, contact number, email address, and so on. These PII data, it's unfortunate that happened. And the company was obviously under the Cybersecurity Act in Singapore. They are slapped with a fine. Yeah. In fact, the fine today, right, in the new CSA Act in Singapore, they introduced it about 2-3 years ago. The act is not just financial fine. These days, the penalty can include jail sentence in Singapore. So if you found to be negligent, like knowingly negligent in your security posture, you could be jailed for 2 years. And that's why CISOs in Singapore are very concerned, right? Their job is to make sure that they do have the due diligence done on all the APIs. Yeah. But anyway, in this particular case, right, what happened was that there is a hash password that was hidden in their application. And from the hash password, the attacker was able to reverse engineer and found that key and then access all the records. Now, the second one is for, actually the second one, sorry, it's the same case study. I was thinking of another case study. But essentially, this particular one was that in a mobile app, what the developer did, unfortunately, was to keep the API key in the mobile app. Now, as you all know, right, it's pretty easy to go and download the mobile app and reverse engineer to it. When you reverse engineer, you'll see everything. And if your key is hidden inside, it will be stolen, unfortunately. And that's why 5 million records were taken. The central banks are aware of all these issues. This is Philippines Bank, the Bank Central. And they put out a paper just on API security control recommendations, right, to all the financial institutions. Similarly, Malaysia has the same. The team in Malaysia has also mapped it to RMIT, right, on the API requirements as well. But the Philippines did this, and we basically mapped to it so that we know where to comply. Now, why APIs have become a hot topic and why is it not well addressed? I think the key reasons has been around the lack of ownership. You cannot leave the ownership to developers. Let me say it again. Cannot leave the ownership of API to developers. Their job is to write functionality and put it out. I think the last thing they have in mind, unfortunately, I'm not belittling developers. I know some of you are developers here. Your job is to put out the functionalities, right? And security is probably not on top of your mind when deploying it. Yeah. So I think the job of security team is to secure the APIs, right? But it does take the whole village to work together to protect your APIs. Everyone has a stake in it. The developers, the security, the CISO, and so on. There's a lack of visibility. So security team usually owns the firewalls and all that, but then the application team owns the API gateway, right? Now, two different products, two different ownerships. And if you ask the security team, do you know what APIs are published? Well, I wouldn't know because I don't own the API gateway. Somebody else owns the API gateway. So the attackers actually know about this. They know the responsibilities ends at where, and that's why they're attacking APIs. They know that nobody's watching the APIs. Now the attacks on APIs are logic-based. They're not rule-based. Now rule-based attack is easy to protect because they can define the rules in your firewall to look for it and block it. But in API attacks, it's all logic. Logic-based attack. And you can't do it in a signature kind of firewall protection. It doesn't work like that, right? So that's why the traditional security just cannot protect it. And API adoptions are fixing the case. So if you look at a super app today, right? Lazada, Shopee, and all these. The app consists of many functionalities, but if you look behind it, they're all APIs. And the APIs calling different data sources. Different sites, different apps, or different APIs in different places. The design for this is sometimes known as BFF. It's a backend for front end. So the backend here, right, are different, even though it appears as the same app to the customer. So what are the risks and what is API security? Traditionally, we use API gateways here and WAFs, Web Application Firewall. These are kind of standard stuff that we would have implemented. For PCI compliance, you also obviously need WAF. But if you look at the top 10, this is the Open Web Application Security Project, OWASP top 10. was recently updated to 2023 in June last year, and the top 10 attacks, a lot of crosses, which means that they don't meet. It's not sufficient. If you have API gateway, if you have a WAF, it's not sufficient, right? So Gartner says, okay, what should you do to address API security? There are a few things. First, you have to discover what APIs you publish. It cannot be like, oh, I don't know what APIs are published. If you don't know what APIs are published, then you don't know, you cannot protect. Right? You must have an inventory first, what is actually out there. Then you need to do posture management for every API. Make sure that posture is correct. Must have, for example, authentication. You can't have an API without authentication. That's especially if there's PII data behind it. You need to be able to do testing, continuous testing. Making sure that it's always up to date. Do runtime protection like rate limiting. Minimally, you must rate limit. Otherwise, you'll bring down the whole server. Right? If you don't rate limit it. Obviously, access control. Only the rights, people with the right tokens can access it. So fundamentally, these are the kind of 5 things you need to put in place on top of your API gateway and WAF. Now, this is kind of financial API. I'm not sure whether you've seen this before, FEX and FA, FAPI. Are these standards common? Yeah? Is that something you've seen before? Okay. This is more for the banks. The FEX is the US based, FAPI is the UK based. It's how you would interact with a bank here. And this would be a mediator. For example, you could interact with a bank. And then the end user that's interacting can directly interact with the bank, or it can go through a mediator or a fintech to transact with a bank as well. So it's a triangle relationship, but all of these communications is via APIs. So where are the risks? Well, there are risks obviously from here. You may not trust this person here, and the risk associated with attacker compromising the bank, the financial institutions here. Or the risk could also come from here to the bank as well. In that, what if this is compromised, right? And attacks come through to the financial institutions. So WIP is a API security company that F5 recently acquired. Yeah, the CTO Chuck, he had this to say: bad guys rob banks because that's where the money is. Right? You rob the bank because that's where the money is. But bad guys are also hacking APIs now because that's where the data is. And data is valuable. Right? If you have heard of the term data is the new gold, liquid gold. So let's talk a little bit about the mobile app. I think we starting to understand that the market is starting to understand that mobile app can be very, very risky. Yeah? The reason is this: when you download a mobile app, right, you can easily reverse engineer it. Right? So this mobile app, and once you reverse engineer it, you would know what APIs are in the app, and then you would then, the easiest one is to look for the login API. And then you would do this thing called brute force injection. Brute force injection basically is credential stuffing. You can buy a user ID password from the dark web, and they do sell. I'm sure Malaysian IDs, in fact, yesterday we were talking to a customer that says that the Malaysian ID, the IC, right, is usually used for login ID sometimes, right? And you could buy these data and then do account creation, fake account creation, just credential stuffing, automated. So you keep hitting until you hit the right one, you log in, right? Or you create accounts. So those are known as brute force attacks. So when you expose APIs, you need to make sure that it cannot be automated. It should always come from a human. You don't want these automated credential stuffing to take place. So bots and APIs, why are they so related, right? The reason is this: once you look at publish an API, anybody can call the API. And for the attackers, they love to call the APIs because they get automated and do all kinds of things they want to do, to compromise it. So this is a real example of an automated attack that's taking place for credential stuffing. And once they turn on the ability to remove that automation, traffic suddenly disappeared. 20% of traffic disappeared because they were serving automated traffic. These credential stuffing that were coming in, right, with the user ID and password hitting their login. Now, what does that mean to owners of this infrastructure? You'll be serving, you need to pay CPU dollars, right, to AWS or Azure, and your CPU is actually serving this automated traffic that does nothing for you. So your bill goes up, yet it's not serving what you want it to do, right? And this is pretty small, 20%. What we've seen when we were interacting with banks in particular, their traffic for automated traffic can be 50-60%. And for commercial accounts like airlines and so on, it can go up to 80-90%. So if you remove that traffic, your bill can go down also. Right? It's not just from security standpoint why you want to remove that traffic, but it's also the cost of it. So OWASP, the Open Web Application Security Project, they do track like top 10 web attacks here, 2021, top 10 API security attacks, and then top 21 for automated attacks. Yeah, so these are quite well documented. Yeah, on how do you, what are these common vulnerabilities? How do you protect it? Very well documented, and you just need to read out and also take notice of it and what would you do to prevent these attacks from happening in your APIs. Now your adversary. Your adversary is also very innovative. They use AI now. So this was published, I think, February this year. And what they do is they use their LLM, large language model. I'm sure all of you may now know about ChatGPT and so on. They use ChatGPT or a large language model to go and create a list of vulnerabilities for any site. So you can go in and buy the data from them. What sites, what APIs are published in a particular site, and how do you log in. And it's done by an AI LLM agent. So the adversary is getting a lot more sophisticated, and you need to be aware and take the right actions. So Gartner on API. Gartner realizes that there's exponential growth also in the pace of API development. Yeah. So number of APIs that developers are writing is just growing exponentially. But then the pace at which we are taking steps, right, to really protect the APIs at runtime, it's not growing at the same pace. So in order to catch up, we must do API security testing early on in the life cycle to be proactive in addressing the API vulnerabilities before it even goes in production, right? So this testing needs to take place, but it doesn't mean that you don't need to do this. You still need to do web app and API protection at runtime, right? So that's mandatory. But shifting left, sometimes known as shift left, to go to development and start testing the APIs when it's being developed. So if you look at the time scale of how you would deliver an API, so let's say day 0 minus n. So day 0 is the time you put into production, let's say. But day 0 minus n, maybe 30 days or so before your production, you started development. And then after you deploy, perhaps if you're compliant to MAS or Bank Negara, there will be some sort of pen test you need to do, right? Every 6 months or 12 months you need to pen test. So when you do a pen test, maybe at that point in time you will find some vulnerabilities from the auditors, right? That when you do pen test, then you address it and you respond to it. Now, what if the pen test could be 90 days later, 6 months later, right? But that means from the time you start development to that time of testing, you've got APIs that could be vulnerable and exposed. And you were not aware until somebody does a pen test on it. So what if you could address this early on in the life cycle of the API while it's being developed? That's the whole idea of shifting left earlier on in the life cycle. So this notion of shifting left comes from the CI/CD. If you have been in a kind of a modern app development, you would know about the CI/CD infinity cycle here, where this is production operation time, and this is development of API with coding, and then production, monitoring, and operations. So what we're saying here is that this is like a life cycle of your API from development all the way to production. And in this life cycle, there will be a few things you would want to do in terms of APIs, starting with API discovery from your code. So just by looking at your code, you can discover APIs, what were actually being coded by developers. Yeah. Then you can look at the code and start testing it during development time. These tools are available. Then you can discover APIs from traffic analysis, meaning runtime. You look at the traffic flowing through the network and you can discover APIs as well. And then you do the runtime protection enforcement. And then finally, here, you can invoke a SaaS service to scan your domain and from outside in view of what APIs are actually published. Quite often, you may be surprised and say, oh, I didn't know that port was open or that the API existed. But the external service, will be able to help you to uncover those. And the beauty is that all these lenses, if you like, lenses of what you can see in your APIs, can all be aggregated into a data lake. Yeah? So that then you can create a full view of your API governance, like PCI DSS or OWASP top 10, or I know GDPR is not important here, but HL7, HIPAA, all these requirements you can meet through a data lake consolidation and see whether you are better at it all the time or you're deviating from those standards. So just some graphical views of what it looks like, in terms of doing this, API security. So this is a screenshot of, I know the visual doesn't turn out very well. There's actually lines here to show how the different API endpoints are automatically discovered. This is API discovery of what actually is flowing through the network from traffic analysis. And obviously, each of these, you can do posture management, and then you can rate limit or protect the APIs if it's not supposed to be there. API discovery from code. So I'm sure a lot of developers using GitHub, GitLab, right? So all you need is just give the URL of the GitHub GitLab to the SaaS service. It will then comb through your code and give you an inventory of all the APIs that the developer is building. Right? So that will give you API discovery, which is a very, very important function. And it may even suggest to you, if the developer didn't write a good code, it will even suggest to you that you should write this API in this manner through LLM AI engine. it doesn't turn out very well. So what it's trying to say here is that after we discover the APIs, right, from the traffic analysis, for example, we will know, okay, these ones were documented by developers, which is good. So developers documented and we're seeing in the network traffic, all good. Then what about these ones? The developers never documented it, but it's happening in the network, which means this is the terminology used is called shadow API. It's not supposed to be there, but it could be a result of poor documentation. Developer never got around to document it, but you don't want a situation where developer had no intention of publishing it, but it's actually out there and it's being caught. And that's not good. We have a situation. So I'm going to share a case study. Have you heard about the Optus case study? Optus. So Optus is a telco in Australia. Yeah, it's the second carrier in Australia, owned by Singtel actually. About 1.5 years ago, they had an API attack. And when they had a data breach, because they know about it when the news got out, right? 10 million records were published in the dark web. And guess who they called, right, when there's a data breach? They called the CISO, the security, head, right? Cyber security head. The CISO says, I spent millions of dollars on my firewall, my next-gen firewall, my WAF, but yet, this attack still happened, right? Now, if you look at, okay, what essentially happened was that there was a shadow API the developer built. The developers built it for their own personal testing purposes, but unfortunately, the developer published it in the API gateway. The CISO was saying that, hey, I don't even own the API gateway, so I wouldn't know that these APIs are published. And attackers know about this problem, right? And that's why from now on, there's no CISOs in the world today that would say, I don't know what APIs are published in the API gateway. No more. They have to do their job and do the API discovery, right? Now that particular API the developer created for himself required no authentication because it's personal API. So there's no authentication. It allows him to make a call and retrieve a customer record. So attacker found it and made 10 million calls and retrieved 10 million records because they do it through bot automation. So now 10 million records are stolen in Optus. It's under investigation. The court proceedings taking place right now. But if you look at it, if let's say Optus had the right technologies, right? First of all, they should have discovered the shadow API, number one. Secondly, it would have been a red flag. Why this API doesn't have any authentication? And the third red flag would have been, why is there 10 million calls from this automated script? So these things, right, it's like perfect storm. Three things that never got detected, and hence, a court case is happening now. So this is also very important, to be able to discover APIs that are really published out there from outside in field, right? So this is another good example of API inventory discovery. And it's just a SaaS service, yeah. So all you need to do is just give a domain name to the SaaS service. You just comb through the entire domain and look for ports open and APIs open. And for every API, we'll be able to tell you, okay, what weakness is there. Like for example, there's a weak job token claim, or it's missing a job token, like in the case of Optus, when there's no authentication at all. It would have flagged out as a red here, as high, to let you know that this shouldn't be happening. Why is there no authentication? But these sort of vulnerabilities that I highlighted, it is then, you can do it in such a way in which it automatically then creates a Jira case or ServiceNow case, yeah, to send to a developer and say, hey, why is this like this? Right? And then maybe they have to go and fix the code and address it. But this is what can be done at runtime, yeah, and discovery. And then Oh, one more thing, yeah. Early this year in February, Azure, Microsoft had the biggest attack. I'm not sure whether you heard about that. The biggest data breach ever in the world was with Microsoft Azure. And the reason was because in Office 365, right, you have the ability to say, I want to stay authenticated. And even if you, let's say, log out, you go away and you come back in again, it saves time, right? So you don't have to re-log in. So that particular feature then allows someone to steal the token, the authenticated token, and use it as to mimic the real person. So the attacker was able to steal the token and then log into Office 365. Now, this is known as a stolen token. And today, any API gateway that you're using today, if you are presented with the right token, you will have to serve. There's no question about whether you assume that the token is trusted. You present the right token, you serve, right? But what if the token is stolen? How do you detect that? So that's where behavioral detection comes in. You need to know that even if you have the right token, I still don't trust you. Do you behave like the normal user does, right? Do you go and look for APIs that don't exist, for example? Is your device ID this device ID the same as the previous one that you were using? So all these things are telltale signs where a token can be stolen. And then you couple that with the ability to detect automation. Usually all these API calls are done through some scripting, and do credential stuffing and so on to compromise your system. For developers, any developers here? Yeah, I'm sure you heard of Nginx. Yeah, it's an open source. Yeah, so Nginx is part of F5. Yeah, it's an open source, very popular open source. You can use Nginx for API gateway, API security. It supports all these modern protocols like gRPC, WebSockets, and so on. It has API security, application security, as well as this. Yeah, you could use it as a middleware, and it's open source. Yeah, to host your applications. Yeah. So that's one way you could use Nginx. A lot of our customers do that. Let me conclude with the last slide here, just to give you a view of what it may look like when you build the APIs. Assuming this is your app here, and you can put Nginx as API gateway right next to your app. You can also consolidate it as one gateway outside, and you may have different roles and responsibilities or different sets of APIs that are categorized differently. But to protect it, the API gateway, you would then look for these sort of services like API security that can be delivered as a SaaS service here. So it's provisioned through F5 infrastructure. And in your infrastructure, so I know you can't see this rectangle very well. This would be, let's say, your data center or AWS. But if you have data sovereignty requirements, this could be within KL, Malaysia, through an infrastructure as a service player here. But the beauty is this: you don't need to have a public IP here. But essentially, your DMZ is here now. This is your DMZ, and this is just a proxy to get out. So because you don't have any public IP here, there's nothing to attack. When you don't have a public IP, there's nothing to attack inside. Essentially, this becomes your DMZ. Yeah, and we'll take care of all the security services, and all these can be automated through CI/CD, single view console to manage the infrastructure. So it becomes simpler. Today, it's in a unique time. It's so easy in a way to set up a new company and get it rolled out. I mean, public cloud can make that very simple and fairly cheaply. In terms of security, it's also fairly simple now, and you don't need to invest in a lot of DMZ firewalling kind of technology. You can outsource it to a provider. Yeah. So thank you so much for your time. Yeah, I'll be around.